All right, now in question number 2, they're asking me to list the data values in the stem and leaf plot here. So they've given us a stem and leaf plot, and we're just supposed to interpret what that stem and leaf plot means. They're not really going to spend any time with single stem and leaf plots. They assume by now, since we did this last year, that you already have all the prerequisite knowledge on how to make a single stem and leaf plot. And that's good news, because you're going to be making a double stem and leaf plot or a back-to-back stem and leaf plot really, really quickly here. All right, so let's go ahead and go back and take a look at this here. We've got a stem and leaf plot. We've got a key for the stem and leaf plot, so we know how this reads. They're telling us here that 1 bar 2 means 12. Now that's important because remember, 1 bar 2 could mean a lot of things. We don't know. Could be 1.2. Could be 0.12. Without having a key, we don't know what 1 bar 2 means. We have a key, so we know that 1 bar 2 means 12, and that these are all numbers that are carrying into the tens place, 2-digit integers. All right, so here they're just asking us what these numbers are based on the plot then. So here we've got a 12, 1 bar 2, 15, 1 bar 5, 40, 4 bar 0, 2 41s, 4 bar 1, 52, 5 bar 2, 57, 5 bar 7, and 59, 5 bar 9. And that's all. They just want to make sure you know how to read the stem and leaf plot here. Now, that's important because here in question number 3 now, we're going to make a double stem and leaf plot. In the double stem and leaf plot, same idea here, a back-to-back stem and leaf plot as they've defined it. All right, you're going to have what is, if we just look at the right side of the plot there, a very traditional stem and leaf plot right there. But then they take that same setup here with the stem and add information to the left for another set of data here. So, taking a look at this here, we've got the number of representatives for selected states between in 1950 and in 2000, not between, in 2 separate years, 1950 and 2000, and we're supposed to put that in a stem and leaf plot. So remember, when you create the stem, this middle part here in the back-to-back stem and leaf plot, the double stem and leaf plot, that's the information that's most consistent, as we described it last year. What's consistent about all these numbers here on this list is they all start with a 1, a 2, a 3, or a 4. So they go ahead and list 1, 2, 3, and 4 in the stem. All right, now we're going to take all the information for 1950 and put it on one side of the stem and leaf plot, take all the information for 2000 and put it on another side of the stem and leaf plot. Now, as far as that goes here, they picked 1950 for the left and 2000 for the right. It totally doesn't matter which one's on the left and which one's on the right. There's no procedure that says it has to be this way, it has to be that way. That doesn't exist. But you just want to make sure you label whatever you decide to do. So let's start with the 2000 data because that's our traditional stem and leaf plot. As you can see, you've got a bunch of numbers here that start with a 1. You've got 19 and 10 and 15 and 19. So a 9, a 0, a 5, and a 9 have to match up with 1 in the stem and leaf plot for 2000. Now, as you can see, they put these numbers here, the 0, the 5, the 9, and the 9, in order from least to greatest. So they're obviously making an ordered stem and leaf plot. All right, here, as we see this, 10 was not the first number actually. 19 was, but 9 is at the end of the list. So obviously they've taken the time to order these for us. All right, the only other number on the 2000 side is 29, so they put a 9 next to the 2. All right, let's go back and get the 1950 numbers. Now, notice the 1950 numbers are also ordered. They are in order from left to right. I know it might seem logical for some. Well, if I'm closest to the 1, why wouldn't the smallest number be here and then the bigger numbers go out? That's just not the way it's done. It's done the same way we read order from left to right. So smallest number on the left, biggest number on the right. So 25 is first, next to the 2 goes a 5. Then 14, which means a 4 next to the 1. 18, which means an 8 next to the 1. And again, since this is in order, the 4 was first and the 8 was second. 43, a 3 next down here to the 4. And 31, a 1 next to the 3. And again, these numbers are in order. Really, the only row that applies to is this first one, 4 and 8. You'll notice a lack of commas here. Stem and leaf plots do not utilize commas. They utilize spaces, the exact same thing you saw last year. Down here, what's most important to us now, anyway, is we got to make sure we get a key. The key shows us how this information is read. What I would do is pick this top row here, which is not exactly what they did here, but it'll work. And you could say 8 bar, 1 bar, 0 is the same as 18 and 10. Notice they did it a little bit differently. They took each piece separately, which is fine. They showed us that the bar to bar 9, which would actually be this piece of data right here, means 29. And then they showed us 8 bar, 1 bar, which is this piece of data right here, means 18. All right, now number 4, we're making a Venn diagram to show how many 8th grade students play soccer. Now usually you use a Venn diagram when you're doing readings, probably most often in a language arts class, because in a Venn diagram here, you're making comparisons and identifying things that are different, comparisons and identifying things that contrast as well. What you do in a Venn diagram is you have these circles that overlap. And in these circles, you're going to list in each region what's unique about whatever topic you're talking about. And then in the middle there, you're going to identify what is common between those two things. So here we're talking about 8th grade students who play soccer. So in the left bubble is going to be all the information we have about 8th graders. And it's about 8th grade students who play soccer. So the right bubble is going to be about people that play soccer. And then in that overlap area, that's going to be where we put the number of 8th graders who happen to play soccer. So as you can see, as we go through the list and count up the number of 8th graders we have 1, 2, 3, 4 8th graders on the list. So that's where this 4 came from here, because there's 4 8th graders on the list. Over here, this is the number of people that play soccer. So as we go through and look at the soccer players, we have 1, 2, 3, 4, 5 soccer players. So 5 people who play soccer here, so there's the 5. All right, now this middle area here is the number of people that are 8th graders who play soccer. Well, the number of 8th graders who play soccer, well, as you can see, we've got one right here, an 8th grader who plays soccer, and another one down here is an 8th grader who plays soccer, and that's it. There's 2 of them. So in this area of overlap there, we write it 2. And now we've successfully made a Venn diagram.